Imagine building a multi-room web application, like an exclusive VIP club. You've designed specific rooms for specific purposes, but right now there is absolutely nobody working the door. Without security checks in your routing, any unauthenticated user can bypass your public-facing pages and wander right into the interface of your admin dashboard. Or consider a user halfway through a long registration form. If they accidentally hit the browser's back button, the application allows the navigation instantly, and all that unsaved data is lost. Even worse, users can trigger the download of source code for lazy loaded modules, sections of your application they shouldn't even know exist. To manage these movements, developers use Angular route guards. These are interfaces that act as checkpoints, allowing you to programmatically control whether a user can navigate into or out of a specific route. Without these guards acting as gatekeepers, your application's internal structure is visible to anyone. You're left with a navigation flow that is unprotected and often unpredictable for the end user. The primary check at your application's front door is the canActivate guard. It executes a logic check to decide if a user is allowed to access a specific component view. Looking at this flowchart, when a user navigates to a protected page, the guard stops them at a decision diamond. If false, it intercepts navigation, redirecting to a login page. If verified, the bottom path opens, rendering the requested component. While canActivate prevents the view from appearing, the browser might still download the code bundle. To prevent that, we use the canLoad guard. CanLoad steps in before a lazy loaded module is even requested from the server. It prevents the browser from downloading that specific code bundle unless the user meets your security criteria. Once a user is inside the application, we still need to manage navigation within nested structures. This brings us to the canActivate child guard. Instead of applying individual checks to every single subpage, canActivate child lets you apply a unified policy to a parent root. This automatically protects all nested grandchild components, like the various sections inside an admin panel. Together, these guards provide a coordinated system, ensuring unverified users are blocked from rendering components, downloading code bundles, or traversing deeper layers. Route guards also manage how your data is handled during the transition. The resolve guard acts as a holding area for your components. When an app needs to fetch data from a backend API, the resolve guard pauses the activation of the route until those tasks are fully complete. This ensures when the user finally sees the new page, they aren't staring at empty templates. The component is fully populated the second it renders. Finally, the canDeactivate guard watches over users trying to leave a specific route. Imagine a user has spent 10 minutes filling out a detailed form and then clicks a link to another section of the site by mistake. canDeactivate intercepts that exit event. It creates a safety net, popping up a confirmation dialog that prompts the user to save their changes or confirm they want to abandon the page. By combining entry, data fetching, and exit checkpoints, developers build a comprehensive protective layer. These guards manage access while preserving the user's progress and ensuring a reliable application experience. So, how do we actually write these 5 routing rules into our codebase? In Angular version 14 and earlier, the standard approach required defining class-based services. As we can see in this legacy code, implementing a simple guard required significant boilerplate. You had to create an exported class, implement the canActivate interface, and write out verbose methods just to return a basic Boolean. Starting with Angular 15, the framework transitioned to functional guards. New types like canActivate-fn and canDeactivate-fn distill that logic into into lightweight arrow functions. Look at this updated implementation. Instead of building an entire service class, developers simply declare a constant arrow function, like offGuard here, and assign it directly to the route object. Angular route guards have evolved from heavy, verbose structural requirements into sleek, reusable functions. This transition gives developers precise control over navigation with minimal code overhead.